Hello everybody, in this video we are going to continue the conversation about systems of inequalities, but this time we're going to use a system of inequality in a real world context. So for these kinds of problems on the back, we're going to do several things. Number one, we're going to identify the variables that we're going to use to set up the inequality. We're going to use the information to set up the actual inequality and system of inequality. And then from there, we're going to graph it so we can find all the different possible solutions to the system. So with that being said, let's go ahead and read through this one. So this one is talking about tickets for a school play. It costs $3 for students and $6 for adults. The drama club hopes to bring in at least 450. So remember and hold on to the word at least, because that's going to help us determine, are we using greater than or less than? Okay, so at least $450 in sales. The auditorium has 120 seats. Let A represent the number of adult tickets and S represent the number of student tickets. Right, the system of inequality representing the situation, and show the solution to the system of inequalities by graphing. So the first thing I'm going to point out is I do have an XY here because we naturally know how to solve for Y and graph and then create the graph for X's and Y's on a coordinate plane. Now they have specifically told us they want A to represent adults and S to represent students. So I'm going to ask you to keep that in mind, but let's go ahead and do X. Our X value is going to be adults. And then so we'll keep on coming back to the A. So for this one, we're going to say X represents the number of adult tickets. And I'm also going to put an A in parentheses to remind you that the A is for adult. We're changing it to X for our own sake. All right, so that means that S is going to be our Y. So those are going to be our student tickets. So that's going to represent the number of student tickets. And we're going to put an S right here to remind us that Y is S and S is Y. All right, we're going to read the context one more time. And it says that it costs $3 for students, $6 for adults, and that we hope to bring in at least 450. So let's think about the word for at least 450. They will be okay if they make 450. They will be okay if they make more than 450. They will not be okay if it was less than 450. The smallest amount they want to receive is 450. Anything above that is okay. So we're going to take that into consideration when we're writing our equation. So because X represents the adult tickets, we know that the adult tickets would be $6. So we're going to say 6X. And our student tickets are $3. So we're going to say plus 3Y. And we're going to use the greater than equal to symbol, because whatever this is would be okay if it's greater than or equal to the 450. If we flip it in the other direction, we're saying that we're okay with it being equal to 450 or less than. And we don't want it to be less than, we want it to be greater than. Okay? So this is our first equation. The second equation, notice it doesn't give us a lot of information, but it tells us that the auditorium has 120 seats. So we're going to say the number of students tickets and the number of adult tickets will either add up to be 120 or less. Okay? Because we can't have more than 120 tickets if we don't have enough seats for everybody. So our second equation is going to be X plus Y is less than equal to 120. And so from here, we're going to solve both of these equations. Now, I do realize I stacked them, so we might have to rewrite one of them and then work it out. Let's start with the easy one. Let's go ahead and let's just solve for Y here, because we know all we have to do is just get rid of the X. So let's subtract 1x on both sides. And so we have y is less than equal to 120 minus 1x. Now there's some information that goes with this one. We know our y-intercept is 120. We know our slope is negative 1 over 1 because we need it to be a fraction. Our opposite slope would be 1 over negative 1. And according to the symbol right here, it's going to be a solid line and it's going to be shaded below. So we're going to say solid below 120. Now, as you're looking at your graph, don't pay too much attention to it because we're going to have to make adjustments so we can fit these big numbers on this graph. So I'm going to show you how to do that in a minute. So I'm going to draw a line because we're going to take 6x plus 3y is greater than equal to 450. And we're going to solve this one for y as well. So let's subtract 6x from both sides. And so we get 3y is greater than equal to 450 minus 6x. All right, I'm going to go ahead and divide by 3. And because it's a positive 3, we are not going to flip our sign. If that would have been a negative 3, then we would flip it from a greater than to a less than. So this becomes y is greater than equal to, if you do 450 divided by 3, it will give you 150 minus 2x. So I'm going to write all my information on the side. We know this is the second line, so our y-intercept is 150. Our slope is negative 2 over 1 because it needs to be a fraction. So the opposite slope would be 2 over negative 1. And because of the symbol right here, we know it's solid. And it's greater than. So it's going to be greater than our y-intercept, which is 150. So we're going to put above 150. So we have all this information. We do not have the correct graph to go with it. So what I'm going to ask you to do here is we're going to add some zeros. That's now 140, 120, 100, 80, 60, 40, 20. Okay, easy fix. Let's do the same thing at the bottom. 20, 40, 60, 80, 100, 120, 140. So this is the fix that we're going to add to it just because we didn't have the right numbers to graph this out. I am going to ask you to label our graph here, our x. This is our x-axis right here. So we're going to say adult tickets. And don't forget to put an A to represent the A from the problem. Alright, I have a hard time writing sideways, so I'm just going to flip this over and put student tickets. And I'll put S, so you know that we're talking about the S. Alright, so we are now ready to graph. We're ready to shade. We're trying to figure out the double shaded region here. So let's start with this one. Our y-intercept is 120, so we're going to find 120, which is right here. And it is telling us to, this one's going to be a little hard to do, negative 1 over 1. So we're going to go down and over, down and over. And so these are all by 10s, then our graph should look fairly like this. All the way down there. Okay. So we know that this is a solid line and we're going to shade below. Now I'm not going to extend this line because technically this is a word problem and we can't have negative numbers here. It just doesn't make sense for it to be negative, so we're going to stop at the axes. And if we're shading below, remember everything down here would be shaded below. So I'm going to take a moment to shade that real quick, and then we're going to graph the second line. Alright, so you can see my line, and I'm getting lazier and lazier with my shade, but you can still see that it's shaded below. So I'm actually going to pause, and I encourage you to do the same, and then graph the second one, then unpause it so you can see if it matches, and then we can set up the second as you're looking at this, it's going to look a little crazy because I did make a mistake. When I graphed the second line, which is this one right here, at 150 all the way through, I went down 2 and over 1 to the right. I just didn't pay attention, and I just shaded everything below that line, knowing that we wrote down that we were shading above the 150. So everything above 150 is up this way, which means we're going to shade above. So I had to go back and correct, but this is a great way to show you that even if you do make a mistake, there are ways to kind of correct and to kind of point out, hey, don't look at this, look at this. So even though I went back and I made this very noticeably on my double shaded region and then went back and realized that doesn't seem right, then I had to go back and get a different color and then correct. Notice that I wrote in, this is not a solution. So these are still not a solution, even though it looks like it's double shaded. And then I drew a little arrow and say, this is the solution set. And then I even went back and added an extra color in there just to kind of emphasize, this is my answer. Okay. So with that being said, there are ways to correct without having to start over. Okay. So we're going to take a moment to look at the second problem and just set it up, and then I'm going to let you guys actually work it out and then graph it and represent your solution set. All right, so if you look at the second word problem, we're talking about Catherine. She's buying apples and pears, and it goes on to tell us that the total number of pieces of fruit that she bought was less than 100. So it is telling us that we're talking about less than 100. So it can't be less than equal to, it's going to be less than 100. And it goes on to tell us that she bought more apples than pears. They tell us to use X and Y, so perfect. We like X and Y, so let's continue to use X and Y. So X represents the number of apples, and Y represents the number of pears. So if we're going to set up this equation, then the first thing we need to do is they don't tell us how many apples or pears, so we're just going to say X plus Y is going to be less than 100, because that's what it says in that sentence. X plus Y together has to be less than 100. So X plus Y is less than. Notice less than, not equal to, just less than. And then the second thing it tells us is that she bought more apples than pears. So we're going to say that X is greater than Y. And so when we get ready to do this one, all right, so for this one of the things that I do want to point out is this one right here, because I know this one's going to give everybody problems. So the first thing I'm going to point out is let's rewrite it, because we're used to Y being on the left-hand side. So notice how it opens up to the X, but it's pointing to the Y. I'm going to ask you to rewrite that. I'm going to ask you to say Y is less than X. Okay. And I know there's an understood one here. I also want to point out that if there's not an extra number here, it's because it's 0. And so our y-intercept for this second equation is going to be 0. So your graph can start at 0 and it can go through the y-axis at 0, and you can go up 1 and over 1. So this one, I went ahead and added the zeros like I did in the previous one. This one's going to be a little bit harder to represent, but just try your best to do this one to go up 1 and over 1 on these graphs, and then solve this one for y. All we have to do is subtract 1x on both sides, and so you can start your graph at 0 and then go through there. Okay, so go ahead and finish this one on your own, and then we can check it when you're in class. So hopefully going over these examples on how to set them up and how to pay attention to those words and graph them has helped. I'll see you guys in the next videos.